Okay, so obviously we have been focused on our sine and cosine functions so far, but you guys know from geometry and from Algebra 2 last year that we have a third basic trig function. That's our tangent function. So let's return to this very same picture that we used to define sine and cosine earlier this unit, okay? So we know that in this picture of our unit circle, with respect to our angle theta, that sine is equal to our x or y. That's a question. X or y for sine? Y. So I'm going to put sine of theta for my y distance, and we know that cosine of theta is our x distance. Okay. I'm actually going to go slightly out of order here. I kind of changed my mind how I want to organize this. So recall from geometry class, what's your tangent ratio? So from your SOHCAHTOA, tangent was equal to? Okay, so TOA, tangent of theta, was equal to opposite over adjacent. Okay? So let's look at this picture now. So with respect to theta, based on what we know about sine and cosine, how else could we refer to the opposite side of this triangle? There's actually a couple different answers that would work here. Instead of saying the opposite sign, what could we call it? Yeah, the opposite side is sine of theta. What's the adjacent side? Cosine of theta. Okay? It is important that we know that tangent of theta is the ratio of sine over cosine. Okay? And it's because of the definitions of sine and cosine that they are the opposite and the adjacent sides. We can also just refer to this as the opposite side is your y value, right? Because that's the same as sine. And the adjacent side is x, because that's the same as cosine of theta. Basically what we're saying here is that tangent of theta is how much you've moved in the y direction over how much you've moved in the x direction. Oh my gosh, where have you seen change in y over change in x? Slope. So a lot of times, now I'm backtracking a little bit, a lot of times we'll say that tangent is the slope of the line passing through the origin and that point, because of the fact that you're looking at the change in y over the change in x. It's just slope. So you'll see tangent being referred to as a couple different things. Obviously, tangent itself, it'll be referred to as the slope of the line. So kind of start equating those two. And then the ratio of sine over cosine. Okay? Alrighty. I'm not going to have you do this right now. But what I would like you to do at some point is I would like you to add all of your tangent values to your unit circle. So all that means is you're going to calculate, I don't have mine handy, but you are going to calculate the ratio of your sine over your cosine values. Okay? Again, I don't want you to do that right this second. But when we're done with this, then I will have you take some time to do that, okay? Alrighty, so Couple of examples. Again, I want you to start equating that slope is really just tangent, okay? Find the slope of the line passing through the origin at an angle of 30 degrees. If it helps you to get a visual of this, you will see on my answer keys that I make this tiny little first quadrant unit circle all the time. Because to be honest with you, there's a whole lot of stuff in my brain. And sometimes I just can't trust my memory and I just need a picture. So I draw my tiny little first quadrant all the time. I know what these coordinates are because I do trust myself enough to know that much. So I draw my tiny little first quadrant because basically if you know your first quadrant, you know the whole thing. So here's the deal. Find the slope. That's essentially meaning find the tangent of 30 degrees is all of what that means. So tangent of 30 degrees, I know, is the ratio of sine of 30 degrees over cosine of 30 degrees. So that's why I drew my tiny little first quadrant, because now I can refer to that to get my values of sine and cosine of 30 degrees from that very first point here. Okay. So the sine of 30 degrees is 1/2. Divided by the cosine of 30 degrees is my radical 3/2. And then I'm going to simplify this. So 1/2 divided by radical 3/2 is the same as 1/2 times 2 over radical 3. I'm just multiplying by the reciprocal, yes. And then simplify. So the 2's cancel. I have 1 over radical 3 and then rationalize your denominator to radical 3/3. If you want to add that to your unit circle right now, be my guest. So tangent of 30 degrees is radical 3/3. You could use that then and do all of your reflections from 30 degrees and you have a bunch of other tangent values. Okay. Can I answer any questions?
Would it like specify if we were supposed to actually like put in our calculator sine of 30 degrees and not use them?
Okay, Lauren has a really good question. This usually comes up exact values versus decimal approximations. Any of those angles that are on your unit circle, I expect an exact value. If I asked the slope of the line through 22 degrees, you're going to have to approximate, okay? But if you're asked for any of those angles, those special angles on your unit circle, exact values, okay? Other questions before we do the other example? All right, so now I want the slope of the line passing through the origin at an angle of pi/4 radians. So I'm trying to get you guys to kind of know your degree radian conversions for those angles on your unit circle. Do you know what pi/4 is? 45 degrees. Okay, so quick way that I think about pi/4. If you know that pi/2 is 90, right? Like halfway between 0 and pi/2 would be pi/4. That has to be 4. I don't know. Makes sense to me. So basically I'm looking for tangent of pi/4, which is sine of pi/4 over cosine of pi/4. And then I'm back to kind of referring to my little first quadrant unit circle that I drew for myself. And what's nice about 45 degrees is that both the sine and cosine of 45 degrees are the same thing. So the ratio of anything over itself has to be what, ladies and gentlemen? 1. Okay? So if you want to add that tangent value to your unit circle, that's fine as well. Can I answer any questions? Make sense so far? Pretty much stuff that you talked about in Algebra 2. Okay, so I found a pretty good video that I just really, I think, did a nice job. It's a Khan Academy video. I know these are Jason's favorites from Algebra 2, but I don't use them often, but it's actually a pretty good one, explaining how you kind of get that graph of the tangent function. We're not super concerned about that graph right now. So I gave you that URL. After we're done with the rest of this, I'm going to have you plug that into Safari and watch that short little video. He just does a nice job of kind of explaining where the graph comes from. So, I don't know, kind of better than probably what I would do. So, we'll just leave it there. So, I'll have you go back to that here in just a little bit. All right. If you flip it over, we have just a couple other things to talk about here. So we have talked about how tangent is related to sine and cosine. That's what we looked at on the front. But what we haven't really looked at is how sine and cosine are related to each other. Okay, and this is going back to how we defined them earlier this unit from the unit circle. So let's go back to our equation of the unit circle. Circle centered at the origin with a radius of 1. That's just x squared plus y squared equals 1. But what have we, in terms of a trig function, defined x to be? Cosine. So I'm just going to replace or substitute cosine of theta in for x and sine of theta in for y. The way that you will see this written more commonly is, cosine squared of theta plus sine squared of theta equals 1. It means the same thing, but this is typically how you'll see it written. That is what you call a trig identity. Have you heard of trig identities at all? Like older siblings, like being like not very happy with them?
I don't like where you're going.
We get into some other trig identities next unit. This is like the easy one to remember. The basic trig identity. Okay, so how we can use that. If you know what quadrant a given angle is in, and you know any one of its 3 trig values, we can use that trig identity to calculate the other 2. Okay, so here's an example of what I mean. You are told that cosine of theta is equal to 1/2. You are asked to find sine and tangent of theta. So what we're going to do is we are going to start with that trig identity. And we're just going to substitute in what we're given. So I'm told that cosine of theta is 1/2. If I substitute that in, that gives me 1/2 squared, because that's cosine theta squared. Bring the rest down. And solve. Okay, so sine squared theta is your variable. 1/2 quantity squared is just 1/4. Subtract 1/4 from both sides. And then just take the square root. That is the exact.
Oh.
So here's the deal. When you take the square root of 3/4, you get plus or minus radical 3/2. Both plus or minus are not the answer. We have to figure out which one it is. Eric, do you have a question or comment? Oh. So here's where you either know your unit circle or you have it in front of you. If cosine of theta is equal to 1/2, what quadrant must you be in? Basically, when is cosine of theta equal to 1/2? What? What's the top right one, Lauren?
1?
Yeah. All right. So I'll just make a note here. When cosine of theta is equal to 1/2, that means we're in the first quadrant. So is sine positive or negative in the first quadrant? Positive. So we take out that negative. It's just the positive answer.
But cosine would still be positive.
In the fourth quadrant?
Yeah.
The bottom right.
Yeah. It would be positive at 60 degrees and then 300 degrees. Yeah. I'll have to think about that. Because your book only gives the positive answer. So let me think about that. Because you're right, it would be positive in the fourth quadrant too. I wonder if that question is supposed to have some other like stipulation that I didn't add or something. I'll look into it, Logan. All right, so we have sine of theta. Let's just stick with the positive one for now. To find the tangent of theta, I'm just going to use the values that I have. So I know that tangent is sine over cosine, so I'm just going to plug in those ratios that I have. So sine is radical 3/2, cosine is 1/2. So I'm not really using my trig identity on that part, I'm just using the ratio. So this is radical 3/2 times 2/1, so radical 3.
So the tangent of 60 degrees is radical.
Yeah. So you could add that to your unit circle as well. All right, last bit here is our reciprocal functions. These you looked at last year in Algebra 2, so this shouldn't be completely new to you. Remember what a reciprocal is? That's when we flip our fraction, right? So if I flip sine, That would be 1 over sine of theta. Oh gosh, do you remember what its reciprocal function is? Of those three? It's cosecant, yeah. And our abbreviation for cosecant is CSC. Our reciprocal function for cosine is secant. Its abbreviation is SEC. And then, of course, our easy one is reciprocal of tangent is cotangent. And its abbreviation is COT. All right. Using our reciprocal functions, we can write one other trig identity. So let's start back with our first one. Our cosine squared plus sine squared equals 1. And what I am going to do is divide everything by cosine squared of theta. Okay, let's look at each term here. So cosine squared of theta over itself, that is just 1. Anything over itself is 1. Any thoughts what sine squared of theta over cosine squared of theta might be? Tangent squared, very good. And then if 1 over cosine is secant, what's 1 over cosine squared? Secant squared. Very good. That's another trig identity. Oops, sorry. You are going to see one other in your homework. Your homework is going to ask you to do a similar type of thing, but divide everything by sine instead to see what you end up with. Okay. Fantastic. Oh my gosh, I remember my honors pre-cal class in high school. Oh my god, long freaking list of these trig identities. We had to memorize them, and holy cow. I remember not only writing my unit circle 5,000 times, but I remember writing all of those trig identities 5,000 times, so I would remember them. What?
What level of math?
What?
What level of math?
That was my honors pre-cal class in high school.
I would take calculus 5.
What?
I would say calculus 5 in college.
There is no calculus 5. It goes up to calc 3.
It said calculus 3 and then it has 2 other ones, and then under it says calculus 4 and calculus 5. The calculus said
Most colleges just label calc 1, 2, and 3. Okay. Let me show you a couple things that I have on Canvas for you. All right. Talked about a couple of these things, but I just want to show you what's on here. Maybe. I mean, you guys have stuff on this page, right? Okay. I don't know why I don't. My computer is not cooperating. Like at all. Come on. All right, well, that's cool. Well, if you go to your campus page, you'll see a couple of things. So underneath where it says practice, it says learn to count by radians. That's the little pie piece game that I was telling you about. So I actually, to be honest with you, did not check this on the iPad. Hopefully does it not work? Ah, shoot. Well, if you have a computer at home, do it on your computer. Sorry. That's really a bummer because it's kind of fun. Like I sat there and like counted like around my circle like 15 times. All right, you'll have to do it at a computer. It's not an assignment or anything. It was just there to help you out. And then underneath practice, again, I have your PDF of your unit circle posted. Just kind of practice on it however you want. I bet this one's Adobe too. Did you check? Oh, it is? Okay. And then I found, they call it the unit circle game. So what this will do is if you click start game, it gives you a couple different things. It'll give you a degree measure, a radian measure, or a coordinate. So you tap on it and you put it -1/2. That would be right here. Yeah. And if you're right, you get a nice green box. If you're wrong, so that's kind of fun too.
Her iPad and that charges so slow.
Yeah, it does. I don't know what's wrong with my computer. Oh, I hate this thing.
Okay, I'm gonna have you guys move over to that. Just for this week.
It's fun, isn't it?
It's a little rewarding.
That is turns Oh, no one did it. I thought you meant.
See, I like your stuff. You're so cozy.
It is. Kind of chilly right now, actually.
It was really chilly.
I didn't feel like it was that same yesterday. And like my ass really.
So no cross.
All right.
Oh yes.
Here's what we are going to do. You're gonna need to clear out kind of the middle of your table. And I gave you all a. Oh, sorry. Gave you all a packet of cards. There are blue cards and there are yellow cards. The blue cards, guys, pay attention. The blue cards are all degree measures, and the yellow cards are all radian measures. So do this. Put them face down, spread them out, kind of mix them up, because you guys are the first ones to use it.
Miss Judy, we did the same thing, puzzle thing.
I don't think I did you did. Just kind of mix them all up. No.
I feel like that's matters.
In a way, in the sense of things that could or may not happen. Critter.